Well, thank you very much. Let's start. Thanks for being this early. Welcome to the IMEKO TC6 webinar series, organized by the IMEKO Technical Committee for Digitalization. So nice to see some new faces. I'm not yet got to know you in person. Yeah, it's also good to meet you again, some colleagues, and also new colleagues. And thanks for joining us, and thanks to the IMEKO organizers and supporters. Just a brief reminder that the website you can visit the TC6 homepage. I will just share that in the chat and remind you that we have this regularly, this activity. I also want to thank the M4D Executive Committee chairs, Jarija and Leslie, that they present during last meeting about their activities. And also to let you know that next talk will be about network sensors, and it will be presented by Aldo Garcia from Senam. This is already being recorded, as you are already agree on that, and made publicly available through IMEKO social networks. You have a chance. We have these recordings available at YouTube, and also in the IMEKO webpage from the TC6 group committee. We have the links to the presentations. Please write your questions in the chat as they come to you, so we will answer at the end of the talk. Today, we'll talk about, I'm the speaker, and I will talk about the digital metrological expert to give you an overview, share with you this progress on the project. And well, it is a pleasure to share with you this experience. Let me open the other. I don't know if I should stop share probably and open the other, the presentation.
Yes, that should work.
Thank you. Please let me know if you can see it.
Yes.
Thank you. So let me introduce you some words about myself. I'm currently working at PTB, German National Metrology Institute, from last year to now. And previously I was working for Senam about 12 years, and before that I was working at NIST as guest researcher for some years. I'm graduated on mathematics and physics, and I have a PhD in mathematics and statistics. Since 2019, just prior to when the pandemic started, I started specializing on the data transformation activities. I've been a member of international committees. Basically, I was chair of a SIM RMO working Group 14 for data transformation for about 5 years, I would say. And also I was part of the Forum for Digitalization at the BIPM. And now I'm currently working at IMEKO TC6 and these activities from 2000 to 22. And I'm currently coordinator of this digital metrological expert project. And basically, so very, very briefly introduction. So what's the concept of this digital metrological expert? What is this? So basically, it's we can have probably many ways to look at it, but I will share some of them. So one thing is to break comparisons. We have talked many of the effort for digitalization has been focused on the calibration certificates, but we want another activity, and we will talk. I will talk with you later about some others kind of metrological activities that require some digitalization or can improve in digitalization format. So in this case, it's bring the comparisons, the international comparison to the digital reality. I would say we can see it also as a product, a tool for automation of data analysis for the evaluation of key comparisons, but it can also be understood as a first step for proficiency testing, also automation of proficiency testing. This also can be seen as a product with validated methods by metrologists of analysis methods. And this product can be operated by humans, but also by machines that allow us to make it interoperable. It can be seen also as the test bed for a wider digital QA tools, quality infrastructure tools development for the future. And this test bed allows us to interoperate with data, services, tools, even standardization like smart standards. And as I was telling you, we also looking at applying this for accreditation, not just for calibrations, but for proficiency testing applicability. This concept is also of the digital metrological expert is oriented to become open source and free of use by everyone. And here I just share with you some of the how it looks like currently. This is not new. In the inauguration or the presentation of the new SI, there was this format of also the digital SI and the idea of using equations that can be executed with this smart standards, pulling information from measurements in the digital format, pulling information or formulas from a digital, I would say a digital a smart document, and also pulling data from digital values of constant or universal constants. And it was showed here with an image at the BIPM ceremony, like the famous equation of Einstein, right? The E equals mc squared. We have the three elements there, constants, universal constant like C, measured value of the mass, and an equation in a digital format so we can, or the machines can execute and interpret and find information in the data to obtain a result for this equation. And by the way that I'm saying that this product can be seen as operated by humans with a user interface, but also by machines in this way, or in this occasion, in this case, like using or providing an API interface. And I share with you here just the access to the website that is running and openly available, and also the address to connect with the API. If you are curious and you're interested, you can get in and try to execute some and learn how to reuse this. So what's come with this interface? of the DME. Well, we look also that this interface to become or to be compliant with FAIR principles, so that machines can act on this knowledge, on this measurement data through a well-defined quality infrastructure. So here, what you can see here is the flow work of the workflow of a comparison, where the participants use they agree on some protocol, I would say, some way of describing the experiments and the data, then conducted the measurements, reporting the measurements to this coordinator, in this case, using the digital metric expert. Then from here, providing reports to the institutes, going back, forward, and backward, and agreeing on the results, and then deciding how to go from there. And then the institute use these two of the participants, use all of this information and the results to provide evidence for updating their capabilities of measurement and calibration at the BIPM. That's the end of the comparisons, right? To keep available or to keep alive, updated these CMCs. But the way it goes for the workflow for the key comparisons is that all this information is kind of private. Well, first it runs in we have several ways to organize, like a round robin, like in the formula of a star, that it goes to the participant and returns to the coordinator to keep track that everything is going well. If there are some deviations, some drifts, then it can be taken into account, and then the next participant and get back to the coordinator, or maybe two participants and get back. We also have this possibility to have many loops or petals, several rings, so that we can, sometimes it's decided by capabilities of the participants or by a way of accelerating the process of the measurements. So if we have many participants, maybe it's a good idea to break this cycle in 2 cycles, so that each loop can measure in a shortest way to get back, and to basically we're doing parallel measurements in the 2 or n rings or loops that we decide to conduct. And then after all this, also we have many other options. I have told you about this drift. The drift can be like linear drift over time, but also we have, in the case of comparisons that are not the key comparisons, that are organized by the RMOs, that has to be linked to a key comparison. That's another kind of a situation that we need to consider. Among others, if we have collaboration about among the results, also it should be considered. But basically, we have this process to go basically linear, with some feedback and some loops that get back, and then we end up with a first draft version, draft A, then draft B after revision, and then when all agree and all the observation and comments are considered, we get to a final report or version. So all of this is conducted kind of a private access, just the involved people, the involved participants, and the coordinator knows, they know about this data, and indeed it's kind of not cryptic, but very conservative, very cautious of sharing information. This is private information, basically. And after it is agreed, then because it is of interest of all the community and the IPM, then after they agreed, then the information becomes public. We have a report, an official report of the comparison. It is shared or published on the BIPM or in a journal or some other way. So more or less, this is the way to go with a comparison. And as I was telling you before, we are adding some new value. It's not just making the measurements and getting a digital format then this kind of system can add value doing some of the job that is very, how to say, like demanding of skilled people. That is basically most of the time they are the profile of these people that makes the analysis is kind of a scare, even because when many people, many colleagues know about these activities, but of course they need or they have another activities, and they are always competing to have some time to do the right analysis and then to review and then to do changes and or attend all the comments, all the observations. So it is very, very demanding. All of these activities are automated in this system, so we are adding value and freeing people time, giving chance to apply or to do some other activities and just kind of leverage the load of work for this profile of people. So basically, how it works now in practice? Well, this agreement that we need to agree on how to document the measurements. Currently, we need this. We have these guidelines from, I would say, in this case, in the case of PTV, we have expert panels, metrologists, a mixture of metrologists from PTV, but also from other NMIs, and also people from industry doing the task at the laboratories. So we have these reports that where they agree how to call these, I would say, this detailed data or metadata on the DCC, how we would call it, so that the machine can access directly and can know what to handle, how to handle the information related to a specific comparison. So by now we have 13 DKD groups or expert panels. That DKD is basically the accreditation body for the German industry. Mm-hmm. And we must think, or we should think about this as pre-normative, as another work to be done, so that they can become like a standard for calling, for naming people, naming this information, this metadata. So once we agree on this, we can then end up with the DCC with the same, I would say, template, with the same content, except for the measurements specific, but in the structure and the metadata will be compatible, will be the same basically. And then it comes a time for use them doing the measurements and reported that in the DCC format or template. And we do that with an API also, or with a tool such as the IMEKO tool, but probably you already are working in your own version to handle the DCC creation. When we have this, we can, all the participants can provide this information in the DCC schema with the metadata harmonized, I would say, with the DKD expert reports. So it comes a time to run get all this information and run the analysis. So that's the next step, right? So we can call the API as I shared with you before, and we can even get, at some point, we don't have this yet. ISO is working on the next version of a smart standards. So at some point in the future, we will have also this connection, probably via APIs, to run the other things that currently are kind of hard-coded decisions that need to be programmed, but in the future it can be just interoperation with another system with a smart standards. Then from there, after doing how we do this magic, I will talk later, but after some processes, then we get the result, and then we can download the report. And from there, we can go with the participants, show what we found with this analysis, and agree if they are happy with these results or they have observations. We can decide something different in the process, change the analysis, and get a new report. And when all they agree, when we all agree, then we can use this as a kind of results for the one of the versions of the report for draft A, draft B, or the final report. And then at the end, we will come up with a version to be provided to the BIPM. So I was talking about this first step about the DKD expert reports. So we have also this open access to this repository. We have several guidelines. Some of them are in German, but some of them are already translated into English. I think there are a few of them in Spanish, but basically we should basically think about the English version. So you can find all these expert reports in this address. You can search for it in the browser, and you just have to filter or look at the ones with this label of DKD expert report, because they have guidelines and they have other kind of publications. Now going into the tip of this magic, how it goes, how it does this DME, this task. I want to tell you, we will look at it a little bit more in a few minutes. But basically, we have on the left way of navigating the system. We are going to, indeed, I will go to demonstrate a live how to go with this using the general access, not the registered users access. So in the visitors access, we enter that as a visitor. We enter a visitor panel, and from there we define the contributions who are participating with which data, with which TC6, and then we end up with a contribution list from these participants, and then we ask just to evaluate, and we get a report, a digital report, and that's it. With this digital report, we go back with the participants, probably the meeting at the BIPM or at your NMI, and then you present the results, and then you discuss and agree how to proceed from there. If you need to do some changes or to explain how we come up with this result, then you do the decisions. If you have to run it again, you do the changes in the visitor panel, run it again, and then you get a new report, and so on until you agree on the results. The differences with the registered user is that you need to log in, and as a coordinator, this access is provided registered users for the coordinators of the comparisons. Then you end up, with you log in, you end up as a coordinator panel, and then you have also the same option. You can define contributions, building up a list of participants with what data, with the data they are participating, and then you can evaluate it. The other thing that the registered user as coordinator can do is, from the coordinator panel, they can upload TC6 into data storage repository. Very basic repository, but it's good enough as a demonstration for this concept. So in this case, the coordinator, basically what happened is that the coordinator of the key comparison receives, after every participant has done their measurements, they send somehow, they share with the coordinator the results. So basically, most of the time they share via an email, a format of an Excel or a file with the data, with the measurements they obtained. So the coordinator indeed work with all this data. The way it is digitalized here is that the participant built up a DCC. He sends the DCC with their measurements to the coordinator, and the coordinator can upload it into this repository, and the system, when you ask to evaluate, the system pulls this information from the repository and conducts the analysis and builds up the report. So how it goes, this evaluation, the sum of this evaluation, we have this detail on the right. We have quantities from the participants in the DCC report. And then the system can conduct a weighted mean as a reference value for the uncertainty for the value to be of the reference value to be assigned in the comparison. But there are other methods and more hypothesis testing here available. And from here, we're going to calculate, once we have the reference value, we go into calculate the equivalence value, ones that are correlated or uncorrelated, depending if the value is excluded or not from the calculation. With this information and this uncertainty, you can compute the criteria for outliers, for evaluating outliers, if they are consistent or not, or the chi-square criterion. And another calculation that we can do with this is the bilateral equivalence value and EM values, or normalized errors values for analysis of the participants. So far, in detail, what it does is basically we have this same workflow, but how this is done is when receive all the DCCs, we read the system read. Then the first step is that it checks the structure and the I would say that they are complete, they are consistent. So we have a DCC schema. We have some requirements also from the self system, the DME. We're working right now in a digital protocol, so it will also analyze the consistency of the participants, the items that have been measured, what are the measurements, and the specified nominal value, and also consistency of the units in the future. These that are lighter are in process; they are not ready. They want that the first two that are here in dark color, they are already running. Then after this checkup of the data, we process the measurements. So what we do with this pre-processing, for example, there are some basically some transformations. Like in the case of temperature, for example, we have some cases where you measure indeed a resistance, an electrical resistance, and it converts these measurements into an estimate of the temperature in degrees Celsius or some other. So this is one case. Other cases that sometimes we report raw values, but indeed the comparison is done on the differences of these raw values against the nominal value. So we have other kinds of transformations at the beginning of the process before trying to get a consensus or a reference value from all the participants. There are other kind of transformations, like in a linking comparison, probably there are some additions or some proportional factors, so that the data must be transformed in that sense. That is previous to the consensus or the reference value. The next is that we can run some test statistics, some hypothesis testing, like testing if the data is homogeneous, or if it is normally distributed, or it is symmetric, or it is stable, or there are instabilities. For example, for testing for linear drift. Basically, that's the idea. And then when everything is with this information, when it is conducted this test, we can select a better or more appropriate model for getting the reference value. And what we have here right now, we have a single measurement, depending also on this, but we have several methods like adaptive weighted mean. We also have access to Bayesian hierarchical models for heterogeneous data. And these, we have three of these methods, like in the hierarchical Bayesian, Laplacian Gaussian combination, or asymmetric student T with Gaussian, or just Gaussian distributions. this is applicable for single measurements like scalars. But when we have some other kind of multiple simultaneous measurements, maybe we will look at applying least squares to simultaneously fit all the values. And also we need to do some kind of linear regression for measurements with drift, with linear drift. There are other kind of measurements like a radiation, what's that, the ionizing radiation, where the measurement can decay, or in the case of biological compounds or organisms, that some of the measurements like the half-life or activity is not exactly linear but exponential. So in that case, we need measurements with a different model for the drift or decay. After we have this, either one single measurement or multiple measurements obtain the reference value, then we can compute the equivalence. Right now, we're using the degrees of equivalence and the normalized errors, the n values, so called. But we are also working right now with chi-square scores for participant consistency analysis. And after we have this, we do some post-processing. This is required basically for plotting because sometimes we end up with values very in a different scale from the raw values that are reported, and it is more convenient sometimes to subtract the nominal value or the reference value and just look at the differences. So probably this may include also kind of unit conversion in the sense of, for example, instead of working with volts, probably it's better to show the plots in millivolts or microvolts, or instead of millimeters in nanometers, so something like that. But also we're thinking about creating reports. Once we have this digitalized, we can, for example, we have several measurements of the same measurement across different whole range of values. We can start thinking about providing support for the CMC's review in a kind of report where you can show how good you did in your participation. If you do well or did good in all the range, or just in the lower range, or in the middle, or the high end range of the values. And that will be connected directly with the CMCs that can be updated or recognized to your institute. And then finally, with all this information, we produce a report, basically. So what we do here is a way we're using the DCC, but the DCC was initially thought for calibrations. So how we are handling is not the same, right? A comparison than a calibration. So how we handling this is that we produce, or we think of a mapping, how to use the DCC with a different, somewhat different information from the comparisons. So we have, as a DCC schema, we have an administrative data section where we put a kind of summary of all of the administrative data for each of the participants. And each of that is one thing, but also we have in the case of the statements for the comparison application, in the statements we include a statement for each of the participants where we indeed copy the whole DCC of the input of this participant into that statement, so that in that sense the report contains each of the reports that were provided by the participants. One report for each participant. So we have, in that sense, a way of checking up, tracing back where this information come from, what we are using during the analysis. If the participant do not agree, well, we have this as a backup to show that we're using this information, and we can track back where it was provided, where via even in the repository, or even going back to the emails of the coordinator. And the other section is the administrative data. Well, we have several DCCs here with measurement results, right, for each item. Then we end up here in a structure where for each item we group together all the results reported for that item, one for each participant. And using all of these inputs, these are basically the values that are reported for that measurement. Then we build up the reference value, the key comparison reference value. I don't know if you can see this. Let me try to choose kind of a pointer. So I'm talking about this. This section is
Hello?
about yes.
हाँ ठीक है हाँ हाँ बोलो बोलो
Oh, I
देखो राजू जब पहुंचने कितना समय लगेगा
someone is talking, please. I don't know.
Yeah,
You
you
can
can.
turn
Yeah, you
off
can go ahead now.
your mic. Thank you. So we have this input data. With this input data from the participants for each item, we build up this key comparison reference value. And then with this, once we have this value and each of the participants' values, we can compute basically the degrees of equivalence. We can conduct criteria, we test for what what's observed, if they are outliers or they are consistent with the key comparison reference value. We can suggest, the system can suggest if they should be excluded from the computation or not. And then you can decide to exclude them or not exclude them. And then we end up with the bilateral degrees of equivalence and the bilateral normalized errors. So far that's about the details of how it is designed and how it works. So what we have right now, I will share with you what we have been doing in practical application. We have this view of the SI where we have built up on top, on the outer circle, we put the CC committees. So for each of the main magnitude or quantity, we related to one of the CCMs, CC committees, I would say. There are some that are not just, for example, the ionizing radiation. The way they measure, they reported in a combination of mass and time, and some of the quantities that are provided or measured by the acoustic groups and vibrations are in the length and time units. So what we have done here, I don't know what is not working. So we have conducted the first international virtual mass comparison. Last year was published. It started on the 2024, but last year was published this result. It was a single item with a single quantity, and it was not measured itself. It was just provided as a virtual comparison. The participants provided a random number, according to their capabilities about simulating a measurement. Then we also have a conducted comparison on temperature, radiation temperature. So we have right now temperature and mass groups in collaboration with this effort. But we have collaborated with these CC committees. Then also we did a second one in the mass group, a second comparison, second collaboration on the cable balance. It was last year in November. It was presented at the VIPM. In this case, the presentation was in charge of Stefan Schlaminger from NIST. Then we also have another comparison for length blocks, for gauge blocks. And the comparison was about the length of the I would say, yes, the parallel, the length of the blocks. And it was just in this case, just the aromat loop. The case of the temperature, radiation temperature, was also just the aromat loop. Even though there were more participants in these comparisons, it was an open invitation, and just some of the European Union accepted or were interested in participating. This was also conducted and presented last year. That was being done last year, up to last year. And now what is going on this year, even we started last year, but it's running right now. We're doing this collaboration with CCQM for quantity of mass. It is a chemical measurement for hemoglobin in human blood. And this has, well, I didn't mention this. In the case of the radiation temperature, we have multiple items with one single quantity. In this case of the hemoglobin in human blood, we are integrating part of the methods from the NIST decision tree. So we are facing this interoperability between systems, sharing information, sharing functionality, or just reducing interoperability of functionality. And we're including variation methods, hierarchical methods, and computation of dark uncertainty. We are also conducting an ongoing cooperation with another group for density of weight masses. So we have here multiple quantities related to the same item. We have the mass, we have the volume, and we have the density. So this is the third comparison that we're collaborating with the mass group. One last thing that we're doing in this ongoing process is cooperation with a group of vibrations and medical acoustics at PTV. So we have this collaboration in this other group. So by now we have 5 of the 8 or 9 groups. 1, 2, 3, 9 groups. We're not using here. We're not mentioning here the other group for units. So now a lab demonstration for the DME. How we conduct this, we need to prepare something for a new D comparison. We need to define the ref types, these references of the that I use to harmonize the TC6, right, for a new quantity. So the problem with that is that we can call it's so flexible to TC6 that if we don't agree, the machines will not understand, will not handle the information or the metadata correctly. So we need to agree on the metadata. See, if we have, for example, a measurement of think about pressure. Well, pressure maybe is influenced by the temperature. So we need to call the same parameter about temperature, environmental temperature of the room, or environment temp, or whatever you want to call this parameter. We need to call it the same in the TC6 format so that the machine can look for it and find it the same way from all the sources for that quantity. That is why it's very, very important to agree on this, probably to reduce the expert reports where they already have done this, or at least part of this task, and we can reuse it and save time on that. So we need to define the ref types, the IDs that we're going to be using, and the ref IDs for example, for the items. We need to identify the items with an ID, and when we report the measurement result for that item, we need to provide the ref ID to that item. So the idea of the recommendation here is to reduce the expert reports that are already available. You can use them. You can also collaborate in this digital vocabulary. There is another ongoing task that is the metrology database, where each ref ID and each ref type, I would say, is being documented, so we can call the same thing the same way. And we can talk the same language, basically. So we need to agree first on this. After we agree on this, then we can, I would say, like tailor a DCC template with these decisions, and then we can share this template with all the participants of this comparison, of this new comparison. So it's basically the same as providing the way we do right now is like agreeing on the measurements, on the dates, on who's going to be participating, what will be the items, and then we basically end up nowadays we end up with probably Excel files with this information, with some tables for each item, what we reported in which units, and how you call each column, what information is provided in each of them, and then you share with all the participants. They do their measurements, and they report on these formats or templates. It's basically the same, but in a digital way for the DCC. So I'm gonna share with you run this live demonstration. I don't know if I can do this at the same time as this presentation. Probably I can do it. Let me see. Let me show you. If you can see, let me know if you can see the system, this other window.
Yes, we see a little window.
Oh, thank you very much. So basically, this is the same that I copy here, right? This section, contribution, and included, reference, excluded, and not contribution. So it's basically this section. So what we will do is in this case, we will run the same comparison, the virtual mass comparison for 1 kilogram. And it is very easy. Just call one way somehow each of the participants. I will just choose NMI1, NMI2, NMI3, and then from here I will select with K1 filtering each of the participants. We have 4 of them: PTB, CRIS, BIPM, and MPL. So I will select this and ask to use it as an included value. This included value is in the computation of the reference value calculation. So I ask to add it, and now we have in this contribution list that will be used for the comparison, we have just one single lab, right? With this DCC. This is the persistent identifier in the repository. It's called the same. It is available. You can use it directly. Then a second laboratory, a second participant, NMI2. And again, I filter with the K1. I will take the second, that is CRIS, and I ask to be included in the computation of the reference value. And now we have 2 here. There are other things that I didn't mention before. Every time you upload a new DCC, it is digitally signed so that you can be, how to say, you can be sure that is the version that you uploaded, because otherwise, in this case, you can verify that is not being modified. That is the original version as was uploaded. So here you have the signature of a third party, a timestamp authority with original values. So every time you check here, it runs again and compares if it is the same as the first time it was uploaded. Then I will continue NMI3. Again, I filter here with 1 kilogram. 1 kilogram. K1. Yes, K1. The next one is the BIPM included, and the final value NMI4, K1, MPL. So, of course, I'm showing here you this demonstration, this live demonstration, but of course, these DCCs were provided by the participants, so they have to build up the DCC, then send it to the coordinator. The coordinators upload it into repository, and now at this time, when they are uploaded, we can just pull them from this window to select them to build up the list of participants, relating which DCC is used for each participant, and that's it. So by now we have the 4 participants. We need to provide a report name. We have several methods already developed. So we have a model for each of them. You have the mass comparison, the radiation temperature, the laboratory medicine for the hemoglobin in human blood, the lead comparison for the cash blocks, the key comparison, and we're working right now in a quarter triple point that I didn't mention, but we expect to have this comparison soon. So I select the mass comparison, and who is the participant, who is the pilot, the coordinating laboratory. I will select the NMI1. The destination file is right now is not required. It takes just to be produced and download. You cannot select other location for the report. And then we just press evaluate comparison. It runs. It generates the report. Probably, I don't know if you can see it here, but it pop-ups a list to keep the file. To download it, I will say yes, keep it. And then I can open it. Probably you can see it, right? Because you, I think probably I'm sharing the whole window. I will open it. This is the report. So we have the administrative data, what software was used. This case is version 4 and the production system. We have the data, who is running this, the items. In this case, was single kilogram, right? One single item. Then the laboratories that are participating. We have here 4. HD is like this initials of the name. I don't know if it is fictitious. And then the customer, in this case, would be the CCM, the Consultative Committee for Mass. The statements that I was telling you, we have here one contribution for NMI1, and here is the persistent ID of the document that was used. The NMI4, again with the PID, and one for each of the participants. And then we have all these sections, the value that was provided by for each of the items. We have the values that were reported for each of the participants. And then we run this analysis of calculated the weighted mean, computed the N criterion if someone is an outlier. No, the maximum is less than 1, so there's no outliers. There are no outliers, so there's no iterations here. Then this ends up with a. And here we have with a reference value, but then we have these plots coded as documents PNG images, but they are coded in base 64. It's a huge document here, so I will not follow anymore on this. So, but when we end up with this report, we can open it with the GEMIMAC tool, or we have another tool for view DCCs in a easier way, probably. I will open up the DCC with the GEMIMAC tool. now to show you. Where is it? Probably I think I should stop now. We're worksheet. I just want to show you this briefly. So I already uploaded this with the IMEKO tool. We go to the preview, the files that were produced because of the plots. We have just here final values, key comparison, bilateral. For example, like this. Well, let's open the first one. And it looks like this plot. So there are no outliers that you can see each of the participant, whether it is were coded as NMI 1, 2, 3, and 4. It is included, all of them. And yeah, basically, that's it. Let me finish this. What we have learned is well, the comparison protocols need to be also machine readable. We're working on that. This schema and the JMWAG were fit for purpose, so we have some. We have to deal with some of these issues because some of the users is kind of confusing. They are doing a comparison, but when they get even the IMEKO, you cannot provide a title for the document. It's a calibration, so that is hard coded. We cannot say in a field or some of the inputs to be a comparison report. We do this in, well, I have been here in probably 10 months ago that I arrived. So the onboarding to a project is very essential to become lean agile. We also need to iterate. The Alliance software framework for the DME has gone through some updates so that new comparisons with multiple items and some of the same kind. We also have very creative stakeholders and users, so they bring new ideas and we need to take care of them and analyze how easy it is to implement them and put some time to do it. Not everything can be done so quickly. What's next? Well, we need to evolution of the architecture from fixed to more flexible configuration. We need to provide comparative analysis of alternative methods. For example, to go in a different decision and then end up with different results and being able to compare them. We have gone from mass to more related categories for simple comparisons to more complex ones, as I mentioned, like density that has 3 quantities related to the same item. A triple point of water that I mentioned that is already there. We are also interested in working with scattering parameters comparison for radio frequencies that have many and vibrations also have many measurements over a range of wide range of frequencies. Gas analysis comparison, we're also working with them to collaborate with them. Also the area of ionizing radiations, probably next year. And we will need additional development for trip analysis, correlation evaluation, and linking loops mechanisms. Just to end up that I want to think that well, I've been talking, we have been working on calibrations and also now on comparisons, on key comparisons, but the activities for metrology at the NMI level, we have several connections. In this diagram, I show you in red all the documents that or products or services, the metrological services that are provided, some by the NMI, some by other organizations like this. We have connection with them, and which of them are already digitalized. So we have calibrations. I will share here, calibrations. Now we're working on key comparisons. This document, this slide was documented in 2022 in a meeting from the same group that we were working. And that moment, NIST decided, or during that time, it was clear that they wanted to work with reference materials, certificates for reference materials, that they say, and they are convinced that they do not produce certificates. They provide reports of certified reference materials. But anyway, they are working on digitalizing that section. NSLI is working on a scope of accreditation for national accreditation bodies. NIST is also working on reference data, standard reference data. PTV is working right now also on reference algorithms, some services to test metrologically programs, code, and the BIPM, CIPM already is working or has worked with the digital SI, the SI reference point. So just to mention here that this idea to look at the whole picture and to decide where to go from here, we are also talking about process testing, but we don't have something yet for conformity assessment, for smart standards, so we're waiting for them to do something. Also, people has asked me about certification, and training is kind of a certified process. We don't have a digital format for that there. Yeah, so basically we have some of these already covered, but there are some gaps to be covered yet. I think that's it from my part. I just, well, I have highlighted what is being, who and what is being working right now. I think that's it, the reference. I want to thank all of you, and probably also, surely also the DMing team here at PTV. Many people have been working on this. Thank you very much.